and welcome to the next part of Learning from Home with Mrs. Beckett on surface area. Let's continue working through our examples. Here we have the blue portion of this shape is what we call a frustrum. An example of a frustrum could be a garbage can, where the bottom part of the garbage can is tapered, and so the top part is a little bit bigger. So a frustrum is really just a cone with a little cone chopped off the top or the bottom, depending on how it's orientated. So in order to find the surface area of this blue shape, I first want to think about what is the surface area of this large shape, the large cone. So the large cone I'm going to call shape number 1. So I want to think about what is the surface area of this larger cone. So the surface area of a cone is pi r squared, that's the area of the circle, plus pi r s, that's going to be the section of the sides. So in order to use that, I need to know the radius. I know the radius of my large cone is 6 centimeters, but I don't know my slant height. So the slant height is this curved edge right here, or this slanted height right there. I do know the vertical height, but I can find my slant height by using Pythagorean theorem. So my base is 6 centimeters. My height is 12 centimeters. So I need to find the hypotenuse C. 6 will be my B, 12 will be my A. A squared plus B squared is C squared. 12 squared plus 6 squared equals C squared. 144, that's 12 squared, plus 36 is equal to C squared. Add those together, you get 180. To go from C squared to C, you need to take the square root of your number, which is 180, which is approximately 13.4 centimeters. So now that I have the slant height, so this C is the same as your slant height, I can now figure out what the surface area of this large cone would have been. So the surface area, I'm going to use 3.14 as pi, but you can also use your pi button on your calculator. And I'm going to plug in 6 for my radius and my slant height of 13.4. 6 squared is 36. And now we're going to multiply our values together. 3.14 times 36 gives me approximately 113. 3.14 times 6 times 13.4 is approximately 252.5. Add those together, you get an answer of 365.5, and my units are centimeters squared. So now that we found the surface area of this entire cone, I need to think about what I'm cutting off. So I'm cutting off this small cone. So I'm going to figure out what the surface area is of shape number 2. So surface area of a cone is pi r squared plus pi r s. So just like before, I need to think about what is the slant height of this small cone. I know that I can use Pythagorean theorem. My radius is 3, that's the base of my right angle triangle. I need to know what is the vertical height of this shape. If the whole cone is 12 and this bottom part is 8, then the vertical height is 12, take away 8, which is 4 centimeters. So now I can use Pythagorean theorem to find the length C, which is also my slant height. So 3 is going to be my B, A is going to be my 4. A squared plus B squared equals C squared. 4 squared plus 3 squared equals C squared. 16 plus 9 equals 6 squared. 25 equals C squared. In order to get from c squared to c, I need to take the square root of 25, which is 5. So 5 centimeters is the length of c, which is the same as the slant height. So now I can work out the surface area of my smaller cone. I'm going to use 3.14 as my pi value, but you could also use your pi button on your calculator. So 3.14 times 3 squared plus 3.14 times 3 times the slant height, which is 5. 3 squared is 9. And now we're going to multiply our values together. 3.14 times 9 is approximately 28.3. And 3.14 times 3 times 5 is approximately 47.1. Now, before we add these together, let's think about what exactly is happening with this small cone in relation to the larger cone or in relation to the frustrum. So if I'm looking at this small cone, I'm taking off the sides of the cone. So the sides of the cone is this part right here, the pi rs. This is the side. And I'm subtracting this from my frustrum. So I'm getting rid of the sides of the cone up at the top. So this 47.1 is what I'm going to subtract from my total surface area of that original larger cone. But I have to keep the bottom of the cone, which is the top of the frustrum in this example. So I have to add this part. So this is the bottom of my cone. And I have to add that to the top, right? So because I have to include the top of this frustrum or the bottom of this cone in that blue shape. So I need to add this part to my surface area of part 1. So when I'm calculating the total surface area, I'm going to take my 365.5. I'm going to add my 28.3, but I'm going to subtract my 47.1. So I needed to think about what I had to do there before I added this together so that I didn't make it more confusing for myself afterwards. So now when I do that calculation, I can plug this all into my calculator. I get an answer of approximately 346.7, and my units are centimeters squared. Let's take a look at the next example. Here I have a house. If I wanted to find the surface area of this house, I would need to calculate the surface area of the top, so my square base pyramid, and I want to take a look at the surface area of my rectangular prism down here, so area 2 or shape 2. Let's take a look at part 1 or shape 1. So the surface area of a square base pyramid is b squared plus 2bs. But this b squared is the bottom, and we're going to assume that this is an open shape inside, so there is not going to be a bottom of my pyramid. So this is the bottom or the base of my pyramid, but I don't need this. So I'm going to take that part out of my equation because I don't need it. So I'm just going to find the surface area of just the 2bs, which are the sides of my pyramid. So the surface area is 2. The base of my pyramid is 10. It's the same as the base on the bottom there. So 2 times 10, and the slant height is given, which is 12. So the surface area of shape number 1 is 2 times 10 times 12, which is 240. My units are feet squared. For shape number 2, I have a rectangular prism. So shape number 2, if I look at my formula sheet, it's 2 times WH plus LW plus LH. So my width and my length refer to the measurements of the bottom or the base, and my height is my 32 feet. I want to think about using the distributive property right now. So the distributive property says that I can multiply the 2 by each of these terms. So I could rewrite this as 2WH plus 2LW plus 2LH. So I have 2 of these sides, 2 of those sides, and 2 of those sides. But I only need one of my top or bottoms because the top is being removed from this shape. So the width and the length is the measurement of my base, which is also the measurement of my top, but I only need one of those. So I'm going to take out the 2 that refers to there because I only need one side. So I've modified that formula so that I can only find the parts of this shape that I need. So I'm not including the top of this prism. So now I'm going to calculate based on what I know. So 2 times 10 times 32 plus 10 times 10 plus 2 times 10 times 32 again, because this is a square at the bottom. So the surface area of part 2, or shape 2, is going to be 640 plus 100 plus 640. And that gives me an answer of 1,380, and my units are feet squared. So the total surface area of this shape is the surface area of shape number 1 plus the surface area of shape number 2, which is 240 plus 1,380, which is a final answer of 1,620, and my units are feet squared. The third example looks at a small brick. So here I have a rectangular prism, and I'm cutting out cylinders from the inside of this brick. If I want to think about surface area, I need to think about, if I was to go back and paint this, what edges would I be painting? Well, I'm going to paint the entire prism, the entire rectangular prism, except for the 4 circles on either side. But I also have to paint the inside of these cylinders. So I have to include those in my calculations. So I'm going to think about solving this by first thinking about, what if I had the entire rectangular prism? I'm going to call that shape 1. So the entire rectangular prism is 2 times WH plus LW plus LH. I don't need to remove any of my sides, so I don't have to do the distributive property first. So I'm just going to plug in what I know. My width will be my 20. My length will be 60, and my height will be 20 as well. So I have 2 times 20 times 20 plus 60 times 20 plus 60 times 20 again. All right. So 2 times 20 times 20 is 400. 60 times 20 is 1,200. And I have another of those, 1,200. Add what I have inside of my brackets, I get 2,800. Multiply that by 2, gives me 5,600, and my units are millimeters squared. Now, if we were thinking about volume for a moment of my 2 cylinders, I would need to first think about this as being shape number 2. I have 2 of those, so I have 2 of my surface areas for shape 2. So what's the surface area now? Well, the surface area of this shape is 2 times 2 pi r squared plus 2 pi r h. But what do these mean? Well, the 2 pi r h is the circles. So this is the circles. So these are actually the parts that I'm cutting out. And then this is the sides of my cylinder. So I'm going to apply the distributive property before I cut out what I know about the circles. Okay? Or I could just cut this out and then multiply this 2 by 2 pi as well. Okay, so a couple of different ways that you can approach this. So let me just show you, if I was doing the distributive property, I would have 2 times 2, which is 4, so 4 pi r squared, and 2 times 2 is 4, so 4 pi r h. But remember, I need to cut out the circles because I'm not including those when I'm painting this object, but I do have to paint the inside of those circles, so the sides of the circles. So I'm only going to calculate the surface area of the sides of the cylinders. So 2 surface areas of just the sides of the cylinder is 4 times 3.14. The radius is, we need to calculate that. So this 10 millimeters refers to the diameter. So the radius is half of the diameter, or it's half of 10, which is 5 millimeters. So my radius is 5, and the height of the cylinder is the width of my brick, which is, so this is now refers to the height of the cylinder, which is going to be 20. So the hardest part is thinking about what parts of the measurements we're referring to. So I'm going to multiply these all together. So 4 times 3.14 times 5 times 20 gives me 1,256. Now, I also need to think about, I was a little bit premature in terms of eliminating this altogether because I calculated my circles into my surface area of shape number 1. So I actually have to go back and think about what these are. So I'm actually going to calculate this measurement. Let's add this here. So I have 4 times 3.14 times my radius, which is 5 squared. So I apologize for that. So I have 4 times 3.14 times 25. So that's this part right here. And when I multiply those together, I get 314. So the circles is what I'm subtracting. The sides is what I'm adding. So I needed to have calculated this so that I could actually, so I don't actually want to remove this from my formula, so that I can subtract it from there. So my total surface area, I apologize if that was a little confusing. Let me know if you have any questions. My total surface area is, I'm going to take my 5,600. I'm going to add the sides of my cylinder, but I'm going to subtract the circles. And that gives me a total surface area of 6,542 millimeters squared. One last example. An aquarium has dimensions of 45 centimeters by 120 centimeters by 60 centimeters. So let's start by drawing what that looks like. So an aquarium, we're going to assume, looks like a rectangular prism. Okay. So my 120 centimeters will be my long side there. My 45 centimeters, usually when it gives you measurements, it's length times width times height. So it's what would it look like if we were thinking about volume. So I know that my 120 has to be the longest side. So this is my width. This is my length. That's my height. So my length is going to be 45 and my height is going to be 60. When I'm thinking about my surface area, I need only one of my bases because my top is going to be open because that's where I pour in the water and I put in my fish. And so I'm going to only have one of the 120 by 45. So you can think about using the formula, or you could just think about what you have in terms of your things. So I have one of the bottoms. I have two of the sides. So I have two of the 45 times 60s. And I have two of the front, so front and the back. And those are the 120 by 60. So now when I'm working out the surface area, I can just do these calculations. So 120 times 45 is 5,400. 2 times 45 times 60 is also 5,400. And 2 times 120 times 60 is 14,400. Add all of these together, you get 25,200. My units are centimeters squared. A word problem needs a good therefore statement. Therefore, 25,200 centimeters squared of glass is required to make the aquarium. Now let's pretend that the glass costs 0.2 cents per centimeter, or 2 cents per centimeter. So how much would it cost for the glass? So this should actually look like this. So 2 cents or $0.02. Okay. So here we have, we're going to take our original amount, so 25,200. We're going to multiply it by our 0.02, and that's going to give us our $504. So therefore, it cost $504 to make the aquarium. So now I want you to try some of the questions from the Check Your Understanding sheet, Part B, question 1417 AC, and Part C, question number 20. When you are finished those and you've checked your answer on Brightspace, or you've asked for help if you need it, then I want you to work on the surface area mission from Knowledge Hook, and go from there. Remember that you love math, and I will see you on school on Monday.